Hey guys, today we're going to cover lesson 7.1 and we're going to talk about polygons. A polygon is a closed figure formed by 3 or more line segments called sides. All right, so now we're going to talk about the first 10 different types of polygons that we have. The first one is a triangle. A triangle has 3 sides. A quadrilateral has 4, pentagon 5, hexagon 6, heptagon 7, octagon 8, nonagon 9, and a decagon has 10. All right, now let's talk about the sum of the interior angle measures. The sum of the measures of the interior angles in any polygon can be determined by the number of triangles that can be drawn within the polygon. Complete the table below and look for a pattern to find the sum of the degrees in any polygon. So what that is saying is depending on how many triangles we can create within our polygon, we can just add those up or multiply it by however many triangles there are and find the sum. So the first one is the triangle. Okay, so for one triangle, we worked a lot with this last semester. The sum of the angles is 180 for a triangle. Now for a quadrilateral, notice how we can draw one line, and it's the minimum amount of lines that we can draw. I know some of you are thinking, well, I can draw another line. Now we're just going to do the minimum. So we can draw one line. Okay, so again, if you just focus on one triangle at a time, well, the sum of those angles is 180. And the sum of these down here is also 180 because we have 2 triangles. So what we can do is, so we have created 2 triangles. What we can do is take 180 times 2, and we get 360 degrees. For a pentagon, we now have 3 triangles. And so we can take 180 because each of those triangles is 180 and multiply it by 3, and we get 540 degrees. The same thing with a hexagon. We now have 4 triangles. So 180 times 4 gives us 720 degrees. Do you guys see a pattern yet? Notice how you're multiplying not by the number of sides, but 2 less than however many sides there are. So like 3 minus 2 gives you the 1. 4 minus 2 gives you 2. 5 minus 2 gives you 3. 6 minus 2 gives you 4. So you're multiplying by 2 less than the number of sides. So now what I want you to do is find the sum for the rest of these. Remember that you'll just take 180 and multiply it by the number of triangles. All right, so here's what you should have gotten. All right, so now let's write the formula. It says if n represents the number of sides of a polygon, then the sum of the interior angle S can be found using the formula. So the sum, we'll say S equals, remember what we were doing. We were multiplying 180 times not how many sides there were, but 2 less than that. So here is the formula to find the sum of the interior angles of a polygon. Okay. Now use that formula to find the first 4 examples. Remember that you're going to plug in your n represents the number of sides. So for number 1, you'll plug in 15 for your n. And so if you really look at this, you're multiplying 180 times 13 because 15 take away 2 is just 13. So if you want to plug this into the calculator, you could just go ahead and do 180 times 13 instead of typing in the whole thing. All right, a regular polygon is a polygon in which all side measures are congruent. Therefore, all angle measures are congruent. So what that pretty much is saying is that you're going to have a polygon where all the sides are the same length and all the angles have the same measure. Now, when you're dealing with a regular polygon and you're trying to find one interior angle, then you can do that by taking the sum of the interior angles and dividing it by the number of sides n. Remember that the top part of this formula represents the sum. 180 times n minus 2, that's the formula that we wrote on the front page. Okay, and all we're doing extra is dividing by the number of sides. And this, again, only works for regular polygons, if all sides are the same and all angles are the same. Usually a problem will tell you, like on number 5, when you're dealing with a regular polygon. Okay, so for number 5, we need to find each interior angle, okay, of both of these polygons, a pentagon and an 18gon. If you remember, we just did the first 10 polygons. So if you look at your front page, we already know what the sum of the interior angles of a pentagon are. It's 540 degrees. So all we have to do is divide that by the number of sides, which is 5. And so you should get 108 degrees. That's what each angle is for this pentagon, interior angle. For a regular 18gon, we don't know what the sum is, right? All we did is up to a decagon. So what we're going to do is we're going to have to use the whole formula. We're going to have to take 180, multiply that with 18 minus 2, and then divide the whole thing by 18. And you get 160 degrees. Now what we're going to do is we're going to find out what the sum of the exterior angles of a polygon are. The first one we're going to do is a triangle, okay? And the way we can find the exterior angle, so for example, I want to find the exterior angle next to 61 degrees. Well, if you remember correctly, together, they make a linear pair. If those two angles have a straight line between them, together they make 180. So I can take 180 minus 61 to find that exterior angle. And so I get 119 degrees, and you will do that for everything. So for all of them, you're going to take 180 minus that number that's inside the polygon. So I got 101 degrees and 140 degrees. So to find the sum, I add these three up, and I get 360 degrees. Now let's see what happens with a quadrilateral. So you're going to have to do the same thing. We need to find the 4 exterior angles. Okay, so take 180, next subtract that from the interior angle, and you get that exterior angle. When I add these 4 angles, I get 360 degrees for the sum. So that's actually the same thing as a triangle, right? It looks like there might be a pattern. Let's find out. So we need to find the 5 exterior angles of the pentagon. When you take those 5 angles and add them together, you get 360 degrees. Wow, look at that. So it looks like we should get 360 for a hexagon as well. Let's find out. And it looks like I'm going to get 360 here as well. So now what can we conclude? Well, I say that the sum of the exterior angles of any polygon is 360 degrees. Now, I know this isn't really a formula, but we can write this down. So we can say the sum of the exterior angles is always 360. So now that we know that it's 360, number 7 and 8 are asking for the measure of each exterior angle. So we're only trying to find one of a regular hexagon or a regular polygon in general. Remember that a regular polygon will have the same angle measures. So you can literally just divide it by the number of sides that you have. So let me try to explain. Let's say we have a triangle. Because we've been working with that, we kind of understand that better. Well, I know that the sum of the angles is 180 degrees. I'm trying to find out what each of these angles are if they're all the same, right? Because it's a regular polygon. Well, you guys know that I'm going to take that 180 and we divide it by 3. And you're able to find one angle, right? So one angle would be 60 degrees. Now this is the same idea, except we're dealing with exterior angles. Okay? So now we are actually dealing with these angles out here. Remember that the sum of the angles is 360. So if I take 360, I can divide that by 3. So each of those angles is 120 degrees. Or you could have looked at the 60, right? But what I'm trying to get you to understand is that you're just going to take the 360 because that's the sum of exterior angles, and you divide it by how many there are. So let's write down a formula. So we can say to find each exterior angle, you take 360 divided by n. Now we can look at number 7 and take 360 divided by, we're trying to find the exterior angle of a hexagon. A hexagon has 6 sides. Therefore, each angle is going to be 60 degrees. Same thing for number 8. You're trying to find each exterior angle of a 24gon, a regular 24gon, right? So I'm going to divide that by 24. And I get 15 degrees. And also observe how the bigger the number, the smaller the angle. All right, for number 9, it says, if the exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? So now it gives us the angle and it wants you to find the number of sides. So what you can do is literally take 360 and divide it by the angle measure, and that gives you the number of sides. So here's my other formula. Notice how it's the same, it's very similar, except all I did was switch these two things. So when you divide by 1, it gives you the other number. And think of it like a fraction, guys, if you're really trying to understand. Just let's say 8 divided by 2. We know 8 divided by 2 is 4. And if we take 8 divided by 4, it's 2. So notice how we just switched those two around and it's still okay. For number 9, we get, and for number 10, we get 9 sides. All right, guys, that's all I have. Thanks for watching.